All right, so today we are just reviewing and looking at more of kind of transformations and what we did, just making sure we get a good foundation of that. Tomorrow we will take our test review, and then Thursday is our test. Okay, so real quick for the first set of problems, okay, they want you to look at this and identify whether it was a stretch, a shrink, a shift, and a reflection, all right, and they want to list all that was there. So I will do number 1 with you and kind of go through there. I'll probably do 1 and 3 to get you started here. All right, so number 1, first things first, we've got to check, is our slope positive or negative? It is positive. So does that mean anything? No. All right, so we know that technically reflection's out of there, right? The next thing to look at, all right, is what is our slope? 5 over 2. You have to decide, is 5 over 2 bigger than 1 or less than 1?
Bigger than 1.
It is bigger than 1. Therefore, we have a vertical stretch. Or you could just say stretch. So you have a stretch by 5 over 2. I do want you to list what the factor is. So you have a stretch by 5 over 2. Now, the last thing to look at is the y-intercept. What is it here?
1.
Yeah, it is plus 1. So that means it is going up 1 unit. Okay. All right, now I want to look at number 3, just because number 3 is a little bit simpler than you think it is, but a lot of students get held up on it. Okay. When you look at it, is your slope negative? No, so reflection doesn't matter. What is your slope? 1. I want to make this note because I don't think I did a good enough job the other day. When m equals 1, that means there is no stretch or shrink. So that simply means you do not list anything. So at this point, we've got no reflection, so we don't have to say anything. We've got no stretch or shrink. What's the only thing left to look at? Shift. Well, our y-intercept is negative 2, so which direction will it go? Down 2 units. Okay? All right, so that's what they're asking you to do on 1 through 6. Okay? On the next set, all right, look in here, all right. Here, they give you some stuff, and what do they ask you to do? Write the equation. So this is actually going in the opposite direction. This is the only really kind of new thing that you're going to see today, and it's not really new. It's just putting stuff where it needs to go. All right, so here they tell you that they want you to shift it down 2 units. So remember, you're always starting with y is equal to x. Well, what shifts stuff down? Is it your slope or is it your y-intercept? Y-intercept. So looking at this, I'm going to leave y equals x, but how do I represent shifting down 2? Minus 2.
Oh, I thought you said up.
I'm sorry, I stuttered. I might have said up, but I meant to say, how do I shift it down 2 units? All right. Now, I'm going to do 2 more of these. The next one I'm going to do is number 9. Okay. What is it asking us to do? Number 9 is asking us to show a reflection over the x-axis. Well, how do you show a reflection? Negative slope. Now, does it say to do anything else? No. It doesn't say to vertically stretch it or shrink it. It does not say to do shift up or down. So therefore, all we've got to do is make it y is equal to negative x. Perfect. Okay. Now, which one? I'll let y'all pick. 10, 11, or 12? 11. Perfect. We'll just go straight down this. Okay. On number 11, they give me a couple directions. They want a vertical shrink by a factor of 1/4 and a reflection over the x-axis. Okay. So I know that, and this is something that you can do. When it says a vertical shrink of 1/4, that's going to deal with my m. So I'm going to write an m next to it. The reflection over the x-axis, well, to be a reflection, I know it's got to have a negative sign. So I just write a little negative sign by it. Well, those are the only two that I'm looking at or affecting. So if I'm thinking of y equals mx plus b, what am I not going to have here? A b value, right? It doesn't say about shifting it up or down. So I know it's just going to be y is equal to whatever happens to my m with an x. So that will equal y equals, well, I know it's got to be a reflection, so it's going to be a negative. The vertical shrink is by a factor of 1/4, and then I've got an x with it. Okay? So those are the types of problems that they are asking you to do on the front. On to the back. Okay? There's two more problems like on the front. But then now if you look at the next set, which is where the bold is, it says given the linear function y is equal to x plus 6, what would the new linear equation be if the following stuff happened? Okay, now this is challenging you to really understand what it's asking you to do. They're giving you this equation, y is equal to x plus 6. Okay, now, here's what you've got to know. They want you to take that equation and shift it down 3 units. Well, shifting down 3 units messes with the what? The y-intercept. Here's the difference. Instead of starting with y is equal to x, you're starting with y is equal to x plus 6. Watch what would happen here if you're trying to figure that out. You've got y is equal to x plus 6. If they want you to shift that down 3 units, that means you need to subtract 3 from your y-intercept. And that'll give you a brand new problem, which is going to be y is equal to x plus 3. So the idea, the concept is the same. You're just applying it to a different kind of problem. Okay? Now, looking at 17, they want you to take it and make it a vertical stretch by a factor of 2. Well, what's the only thing that messes with vertical stretches? The slope. Well, what is your slope there? 1. So all you got to do then is do, for your slope, you would say, hey, well, it's really going to be 1 times 2, which is 2. So that means your final answer will be y is equal to 2x plus 6, because they don't ask you to change anything else. They just want it multiplied by a factor of 2. Okay? Now, the reason that I made you write this out is if you ever see this in the future, sometimes your slope will not be 1. When it is not 1, that means you got to multiply it by whatever it is. That's why I'm showing you all those steps. Okay? All right. And then the last set of problems is they ask you to rewrite each of the following in slope-intercept form and then talk about what happens to it. Okay? So, I will do number 19 to get us started. They want it in slope-intercept form. Well, we've been doing that for a couple weeks now. That means you need to get y by itself. So looking at this, that means I'm going to subtract 7x from both sides. And I'm left with y is equal to negative 7x plus 4.
And then you do the thingies.
Okay? And then you do the thingies. You're exactly right. Is there a negative on my slope?
There is.
So that means it is a reflection. Okay? Is my slope bigger than 1 or less than 1? So that will be a stretch. And what number is it? 7. So you've got a stretch by 7. And then the last thing, is my y-intercept positive or negative? So it's going to go up, how many?
4 units.
4 units. So those are the two things that you need. Would you like me to work one more?
Yes.
Okay, pick one.
22.
22. All right, so 22. First thing I do is I look. I need to get y by itself. So I'm going to subtract 11x from both sides. Negative y equals negative 11x minus 4. Now, I'm not done here. Why? Because of the negative. How do you undo a negative? You can multiply or divide. I tend to say divide, but you've got to divide everything by negative 1. So that means you end up with y is equal to, two negatives make a 11x, and then again, two negatives make a, so you get a plus 4. So that is our new equation in slope-intercept form. So now we've got to list what's happening to it. Is there a reflection? No, there's no negative. Is it a stretch or a shrink? Stretch, since 11 is bigger than 1, so it's a stretch by 11. And then, is it shifting up or down? Up 4 units. The reason that it is going up is your 4 is positive. Okay? All right. So what I'm going to do is I'm going to let y'all work. I'm probably going to give you the rest of this class period. And then when we get back after lunch, I'll see what questions you have. And then from there, we'll work concept checks. Because the concept checks are 8 questions and 4 questions. They're not very long. All right. Ready, set, go.